Okay, I think I'm recording. Okay, guys, I believe I am recording. It kind of started weird that time. Not used to this. Technology still drives me crazy. But here we go. Solving rational equations. So, here is the big thing. We are no longer simplifying, we are solving. I am trying to cut this lesson a little bit shorter. Not because it's not important, but because this is the first time I have used the word solve instead of the word simplify. There is a huge difference in mathematics. So huge that when we do go through this lesson, as soon as we're done, then we're going to start reviewing. And I actually built in one entire review session before this test, which I did not want to do too much of just to save time, but it really is important here. So, once again, this is something I call recipe mathematics, where there is a step-by-step procedure to follow, and if you do that, you will get the result you want. So before you do anything else, pause it, take a picture of this, or jot this into your notebook, because solving rational equations, here's the recipe. It starts at 1, ends at 6. Okay, here we go. I have 15 practice questions for you. So on this one, I think, what are we at? Unit 3, Video 7, Solving Rational Equations. It says solve each of the following. Check for any extraneous solutions. Extraneous solutions, same thing as apparent solution, means an answer that you get, but you really can't, it doesn't really work when you plug it back in. So here's the thing with this. You only have to worry about apparent solutions or extraneous solutions in equations that have variables in the bottom. So take a look at problem 1 while I'm still here. There are no variables in the bottom. You will not have to worry about apparent solutions there. Take a look at 2 and 3. What do you think? I think you don't have to worry about apparent solutions there. Same thing with 4, 5, but when you hit number 6, here's what would be an apparent solution or an extraneous solution. They're synonyms. For number 6, please look at it. If my answer was 0 and I plugged it back in, that means right here, x equals 0. I would have 3 divided by 0 then if I plugged it back into the original. You cannot divide by 0. In mathematics, we have so many rules, but one rule we never break is we never divide by 0. Please take a look at problem 7. Look at the bottom right here. See this? In the bottom of number 7, if I got an answer of -2 when I solved number 7, if my answer happens to be -2, I would plug -2 back in and I would get -2 plus 2 is 0. It would mean I have a 0 in the bottom. That can never happen in mathematics. This whole chunk of the statement here then would say 5 divided by 0. Well, you know what? This is where people get confused sometimes. If I have the number 0, let's think about what does 0 represent? For me, how much money do I have? 0. How many friends do I have? 0, right? If you have no friends like me, and let's say you divide them up into 2 groups, you still have no friends. But if you have, let's say, 2 friends and you divide them up into 0, okay, that's why you have no friends. Sorry, that was a joke. But what I'm saying is you can't do that. You can't take something and divide it into nothingness. But you can take nothing and divide it into as many pieces as you would like. You can totally do that. So let me get rid of all of this stuff that I just did so it's not in the way when we come back. But what I'm trying to say is an extraneous solution is any value that you find that you would have to plug back into the original problem, and it would make the denominator 0. So, just real quick, anywhere. It doesn't have to be every part of the problem, just any part. So see problem 9 here? We haven't even tried to solve it yet, but I can tell you, if I get an answer of -3, it'll make that guy 0 in the bottom. Bad news. It's not a good answer. Think about it. 1 minus x. What would x have to be to make that thing a bad answer? Well, it would have to be a 1. If x was equal to 1, then I'd have 1 minus 1 on the bottom. And guess what? That'd be 0, and that'd be bad news. So when it says in the instructions, solve each of the following, check for any extraneous solutions, what you should do is keep an eye or an ear open for what would be a bad answer. And then go about doing your algebra, solve the problem, do all that good stuff, and then come back and check it. Thinking, okay, if I get the answer 4, I know that's going to be bad, or if I get the answer 5, that's going to be bad. Keep that in mind. Now, there's 13 questions. Here's the remaining 2. There's 14 and 15. Oh my God, that's very faint. That's 14 and 15. Then, here's the answer key. You'll see this guy right here. Okay, in mathematics, one of the cool things about mathematics is we never have to type a paper, and we never have to use MLA format or whatever format they want you to use, because we have shorthand for things. This means no solution. This is the Greek letter phi. The Greek letter phi is a circle with a line through it, and it stands for no solution in mathematics. I don't want to write the word. None of these answers that I got work. See, you can sometimes solve an equation in mathematics algebraically, but when you plug all the numbers back in, it doesn't actually work at all. There's no real answer. So, I'm lazy. I'm not going to write out the words no solution. I'll write this instead. So number 15, guess what? The answers that you're going to get for 15, well, what would make the bottom part of this 0? 5. 5 would be a bad answer. What would make this part a bad answer? -4. And then when you watch my lesson, you'll find out what to do about this. But do remember, you cannot divide by 0. So any answer that creates a 0 on the bottom is extraneous. But you can have 0 in the top of your answer all day long. Some people get those two things confused, and that messes them up. So please be careful of that. Okay, enough of that. I'm going to get rid of all these marks I made. So I'll leave the one that says no solution, because that's what that symbol means. But let's begin. Let's start playing with stuff. So here we go. Example 1, example 2. Well, here, 1. This is something you learned back in the 7th grade. This thing is called a proportion. And if you are looking at this, thinking to yourself, you know what? I could just cross multiply and set them equal. Well, heck, you'd be right. That would be the best way to do this, and that's what I'm going to do. Here's my first thing in the recipe. If the problem you're looking at, if the problem is a proportion, what are you going to do? You're going to cross multiply, set them equal. But if it's not a proportion, then you have all these other steps to do. So let's go back and finish this one. And I go, hey, this thing is a proportion. So if I cross multiply, I get 6 times x plus 4. On the other side, I get 2 times 2x minus 3. And I can solve it. I distribute. This is back to good old Algebra 1 now. I'm like, woo, this is a breeze. And what's that? 4x minus 6. And then I'm going to move this over. Whoop, let me give myself some room. But then I give it away. There's another example there. I end up with what? 2x plus 24 equals negative 6. I'm going to move this over. I'm going to take it away. And I'm running out of room, so I'm going to go over here. And I'm going to say 2x equals negative 30. So what is x? X equals negative 15. Now, x equals negative 15 is a fine answer. I like it. It's not extraneous. If I put negative 15 here, it's not going to make the bottom 0. If I put negative 15 here, it's not going to make the bottom 0. So I'm good. That's a valid answer. Yay, I put a star next to it. I move on with my life. But not all proportions are like they were in the 7th grade. So let's look at how did we advance over the years, kids? Well, let's try this one. It's still a proportion. There's one fraction equal to one fraction. That makes it a proportion. So I cross multiply. And on the one side, I get negative 21 times x plus 2. What does it equal? It equals x times x minus 4, right? That's how we solve a proportion. But when I do that, well, over here I got a little bit more work. Negative 21x minus what? 21 times 2, that's 42. What's it equal? Over here I have x squared minus 4x. And now I got a decision to make, because back in the 7th grade we didn't get a quadratic. We didn't get this nonsense in the 7th grade. But I see that the highest powered thing is positive. So which way do I want to move everything? I want to move everything in this problem to the right-hand side. I want to move this guy to the right-hand side. I want to move this guy to the right-hand side. So if I do that, then I would combine my pieces. I would put this stuff over here. I would write it in the correct order. And it would then say what? It would say x squared is already there. It's positive. What's this piece? That's going to be plus 17x plus, well, there's a 42. Everything's on one side. What must be on the other side then? 0. There we go. We have a quadratic. Now, you can do quadratic formula on this. You might do that. You might go, dang, I don't know how to factor that because that's a big number and that's a weird number. Yeah, if you try quadratic formula, you could do it. However, I want to save a little time. I told you at the beginning, I don't want this lesson to take forever because I want to give you enough time to practice and ask questions, because this is the first time I have used the words solve. And that's a big, big thing for me today. So here we go. X and x gives me x squared. Now, it ends with a positive 42. So I'm going to let you in on something. If it ends with a positive number, it means whatever this is, it's a plus sign, it means there's got to be 2 plus signs. Because the only way you can multiply two numbers together and get a positive is a positive thing times a positive, or a negative times a negative. But if the first chunk of the puzzle is positive, that means you can't have negatives. It's a cool trick to know. Then here's the other thing. Not many people are walking around going, you know what, 42, there's a lot of different ways to break it down. 1 times 42, 2 times 21, there's 6 times 7. But you know what? Nobody goes, you know what, I bet it's 3 times 14. It is. You can double check me, I promise you that's correct. So what are my answers? Because it's a quadratic, I have 2 answers. One of them's negative 3, the other one's negative 14. Remember, whenever you see parentheses in mathematics, it is code for set it equal to 0 in your mind. It really is. It's never false. So the answers are negative 13 and negative 14. So what do? We look at the original problem and we say, hey, original problem, if I put, see, the only place it can ruin it is in the bottom. You can divide by 0 all day long, but if I put negative 3 in the bottom where the x is, that's not a 0. If I put negative 14 in the bottom, that's not, I have 2 valid answers. Yay, 2 of my answers are valid. Guess what? You write down both answers for the solution because you have solved. See, everything we've done up to this point has been simplify. When you simplify, sometimes you get a number for an answer, like 3 or 7 or 1 or whatever. But that doesn't always pay off. That's not always true. When you solve, you always get a numeric answer. You always get a numeric answer when you're solving, because these are equations, not expressions. Everything we've done so far has been an expression, and I'm going to make a big stink about that when we get together in the Zoom room. Okay, here we go. You ready? See that guy? That is an equation that is not a proportion. That is not a proportion. But I wanted to put the very first equation on this that's not a proportion. I wanted you to see this is something we've already done. We've done this in Algebra 1. In fact, we had to do this when we were in Unit 2. I'm going to fraction bust. I am going to fraction bust. I do not want to deal with fractions. I don't like to work with them if I don't have to. So what I'm going to do is I'm going to take the entire thing here and I'm going to multiply by the LCM. When you are solving, not simplifying, when you're solving, we call it the LCM, the least common multiple. It's the same concept as a common denominator, but guess what? When we're solving, we don't want to get common denominators. We want to get rid of common denominators. So that's what fraction busting is all about. I'm going to take everything here and multiply it by 10. Everything gets multiplied by 10. This gets multiplied, that gets multiplied, the last guy gets multiplied. If you multiply an equation all the way across by the exact same value, you are not changing it. You are adjusting it, but you're not changing it. Check this out. 5 goes into 10 twice. So I get 2 times x, that's 2x. Here, 10 goes into 10 once. 1 times 3x is 3x. Then, 10 times 7, well, that's 70. I got rid of all the fractions. I'm going to now move this over. And I'm going to move this over. And I get negative 1x equals what's left on the other side, 70. I divide by negative 1. My answer, since I am solving, is negative 70. That's my answer. Hey, check out this example. We've done something like this. It's called fraction busting. We use something called the least common multiple, and we'll talk about this in class too. If you get confused, you can ask me all kinds of questions, but we get rid of fractions if we can. You know, in Proportion Town, let me scroll up real quick. In Proportion Town, we get rid of fractions because we know how to cross multiply. Look, this first example, we know how to cross multiply, gets rid of all the fractions. But when the fractions can't be cross multiplied because it's not a proportion, we can still make it work. Okay. What did I do? I multiplied by the LCM. Let's look at this one. Hey, what is the least common multiple now? Well, think of it like the common denominator idea, but you don't want to give everybody a common denominator. You want to get rid of the denominator. But it's the same concept. When you're adding and subtracting, you keep the denominator. It's called a common denominator. When you're solving, you want to get rid of, you want a fraction bust, get rid of it, but it's the same thing. To get rid of the bottoms here, well, you need an x to make this guy go away, but you need a 3x to make this guy go away, and this guy's got a 1, so he doesn't even care. But I'm going to multiply everybody here. I'm going to get rid of these arrows. I'm going to get rid of everybody by multiplying by 3x, because 3x is the least common multiple. And in the first multiply, x's go away. I get 3 times 1, that's 3. Minus, in the second one, everybody goes away. I get a 4. What's it equal? Well, it equals what? 3x. Because 1 times 3x is 3x. Now, 3 take away 4, that's negative 1. It equals 3x. I'm going to divide by 3. My answer, because I solved it, is a number. My answer is a number. It's negative 1/3. Now, the only answer that would make this equation bad, the only answer that would be extraneous here would be x equals 0. If x was equal to 0, then I'd have 1 divided by 0 here. That's bad. What's 3 times 0? 3 times 0 would be 0. That would be then 0 in the bottom. That's bad. All it has to do is ruin it in one location. Doesn't have to be several. And it's a bad answer. But you know what? My answer was negative 1/3. So my answer is fine and dandy. It's fine. Leave it alone. It's not this one. So in my mind, I'm thinking if I get this answer, it's a bad dude, but I didn't, so it's a good dude. Let's move on. We're taking a little bite each time. Oh, what the heck is this thing? Now, the thing with this is I see my buddy. I'm like going, whoa, I recognize you. You're the Safe Driver Save 40% guy. I don't know, that commercial's on TV lately, so I keep thinking about that. Here we go. I can factor that. What? I can. Check this out. I'm going to scroll up to the top real quick. That was quick. If the problem is a proportion, it's not a proportion. Otherwise, factor any denominators if possible. This may help you identify the LCM. Let's go down now. See, the second step is sometimes you can factor the bottom, and if you can, do it. Because look what happens here. This guy is like my common denominator idea. This guy's my LCM. I'm going to use him to fraction bust. I'm going to get rid of every fraction. I'm going to take this whole thing, every single chunk, and multiply it by x plus 3, x minus 3. I'm going to use a different color because now it's looking a little more complicated. So I go x plus 3, x minus 3. I'm going to multiply this in. And then what do? You tell yourself, hey, in the first part here, what's going to cancel out? The x plus 3's will cancel out. What will I be left with? I'll be left with 1 times x minus 3. Plus, what's going to happen when I do the second multiply? The x plus 3's cancel, the x minus 3's cancel. I get left with a 5. That's it. I get left with a 5. What does it equal then? Well, in the last part, when I do this last distribute here, these guys are gone. I get left with a 2 times x plus 3. Let's clean this baby up. If I were to do that, I'd get x minus 3 plus 5 equals, let's do this, 2x plus 6. Let's make this smaller. I can put those together. And I'm going to call this x, plus 2 equals 2x plus 6. I'm going to move this over. What the heck? I can. I get minus 1x plus 2 equals what? 6. I'm going to move this over. And I end up with negative 1x equals 4. Divide both sides by negative 1, and we're home free. What's my answer? Negative 4. Now, let me ask you. There were 2 answers at the beginning of this problem that would have been bad. Right? Like the Billie Eilish song. One of the bad guys would have been 3. The other bad guy would have been negative 3. But my answer is negative 4. So guess what? It's too legit to quit. I would say, congratulations, that's my answer. Right? Too legit to quit. That's MC Hammer. By the way, that song, if you listen closely to the words, it's about checking for apparent solutions. You have to listen to the words in your music, boys and girls. All right, what do you think about this one? Do you think the bottom factors anywhere? Do we use step 2? Do we? I would say yes. Because everybody forgets about GCF. GCF is the first lesson in factoring. So I'm going to take out the x, and then I'd get x plus 4. I surely would. And then I go, you know what? That dude is also the LCM. Not the GCF, but I took out the GCF, and it helped me find the LCM. See, this guy's x plus 4. This guy's x. This guy's everybody. So here we go. I'm going to multiply the entire equation by x plus 4. Let's use a different color. How about green? It's going to come in. All right. You know what? Why don't you pause this for a second, do it yourself, and then check and see if you match up with me. Go ahead. Pause. You didn't pause. Pause. Okay. Unpause. I don't know why anybody would say unpause, because you would already be unpaused. Here we go. Let's see what we got. If I multiply the first set of stuff here, the x plus 4s will cancel. I will get a 3x out of that. Then I'll have an equal sign. The next part, the x goes away. So I get 1 times x plus 4. Well, that's just x plus 4. Plus, everything goes away. I get left with 6x plus 12. I surely do. If everything cancels out, I get left with that. So guess what? Why are we doing this? Because we hate fractions. It's called fraction busting. And we get it done. Now, wait a minute. Let's go back to our rules, because I called this recipe math at the beginning. Let's go back up. So here we go. Ready? If it's a proportion, blah, 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 we do that. Yeah, I know. Otherwise, factor denominator, help you find the LCM. Done that a couple times now. Multiply each term by the LCM in order to cancel out any fractions. That's what I've been doing. So let's revisit. Now, clean up whatever's left over. Foil, distribute, do whatever you have to do. That's what we're working on now. We're doing this. Solve the remaining equation. That's easy. Once we get it pretty, it's easy. And then we check for extraneousness. Okay, let's go back. Let's finish our lesson. We're almost there now. We have every piece of the puzzle. So what can we do? We distribute it a little bit up here, right? Now we're going to combine some like terms on this side. X and 6x is 7x. 4 and 12, that is 16. What's it equal? It equals 3x. And then I don't want this to be just sitting there all by itself. Let's move that 7x over, right? Let's move this guy over. We'll take it away. We'll move it to the left, to the left, to the left, to the left. See, Beyonce wrote that song about solving equations. So now we're going to divide by negative 4. Yeah, we are. And we're going to say x equals negative 4. That's my answer. Hey, wait a minute. If I plug negative 4 back in here, it's going to make the bottom 0. That's not good for us. We cannot divide by 0. So, hey, I told you guys, be on the lookout for this thing. It's called the Greek Letter phi. It represents no solution. This is a bad answer. It's a bad guy. So we say no solution. Now, me personally, I do not want to write out the words, there is no solution for this equation. Instead, what do? I just write that symbol, because that is easier for me to do. And that's what I did here. Wow. Let's go on, because here we go. This is the granddaddy of them all. We got one left. We got one more to go. It's right here. Hey, it's not a proportion. Definitely not. That's two fractions on the left, one fraction on the right. That's not a proportion. Remember, proportion means you have one on each side. Let's break it up then, because we're going to go to step 2 then. We're going to factor this baby up, and that's what we're going to do. Then I go, hey, guess what? That is the cool guy. That is the LCM. We're going to multiply this whole thing by x plus 3, x plus 4. It's coming in. In the first spot, I'm going to get 2x minus 1 times what's left over, times x plus 3. So you're telling me I'm going to take a binomial times a binomial. Wait a minute. Shouldn't this be in parentheses then? Because I am going to have to FOIL. I am. Oh, wow. Minus x times, well, what? X plus 4. It looks like that's what's left over. What's it equal? -1, because everything gets obliterated over here. So let's see. You guys try and finish this one. Let's see. Oh, wait. I forgot I had one more to go. Ooh. Let's see. So we FOIL. Let's clean this up. And I'd get 2x squared plus 6x minus 1x minus 3. The negative goes with the x, so I'd get negative x squared minus 4x equals -1. Let's smush this guy down. They go together. That's x squared. 6x take away x is 5x. Minus 4 more x's is 1x. Then I have what left over here? It looks like I have -3. But what's it equal? It equals -1. I can't do anything with that. It's a quadratic. If it's got a power of 2, that means I have to set it equal to what magic number? 0. So I have to move this over. And I will then have no room to work because I have one more example. So I'm going to move this over. And I say x squared plus x minus 2 equals 0. And let's see. X what? Plus 2, x minus 1. Oh, beautiful. There we go. Yay. So I got -2 for an answer. I got +1 for an answer. And I look at the original and I go, oh, both of those answers are legit. Hay dos respuestas. Sí, es la verdad. -2 and 1. We're good. So we have 2 answers. So guess what? We could have 1 answer. We could have 2 answers. We could have no answers if there's no solution. So let's see. Here's what I want you guys to do. I am going to work this problem out, but this is the only one that we saw that looks like this, and then we're done. I want you to try and work this out. So pause it, work this one out, and then unpause it and check and see if you got it right. So ready? Pause it and try it. And now we're back. So here we go. I look at this, it's not a proportion. I'm going to factor out the 2 because 2 could be a GCF. And then I go, hey, look at that. And then I go, oh. So it's actually kind of beautiful in a magical way. I'm going to get this X thing out of my way so I have some room to work. I'm going to change colors and go to red. And I'm going to take this whole side here, this whole thing, not whole side, the whole thing. And I'm going to multiply it by the LCM. That is my LCM. And then what do I get? I get the 2 to cancel. I get the x plus 3's to cancel. I get left with 5x plus 1. Plus, I get the x plus 3's to cancel, but I still have 2 times 7, that's 14. But what's it equal? On the outskirts of town, way over here, okay? 2's cancel. I get negative 1 times x plus 3. Negative 1 times an x plus 3. What does that equal? Negative x minus 3, or negative 1x minus 3. Hey, I don't have a quadratic. Cool, let's solve this one. So I'm going to add it over. Add it over. I get 6 x's. Oh, wait, I could have smushed that together. I could have made that 15. But what's it equal? It equals negative 3. You better get over there, 15. So let's move it over. And I end up with 6x equals negative 18. Vamos a dividir. Dividimos. Recibimos 3 negativo. Pero 3 negativo es mala. Or malo. Es un número malo. It would be malo. Negative 3 is bad. Negative 3 makes that 0 if I plug it in. Heck, if I plug negative 3 back in here, it makes it 0. So, just a reminder, how many answers can we get when we do this? 1, 2, or absolutely none. There is no solution to this. This guy is called apparent. And that is why I made such a big stink about apparent solutions at the beginning of this. It's like Mom used to say, when you're solving a rational equation, you got to check for extraneous solutions. It's true today as it was when Mom said it the first time. So, guys, I'll see you in class. I hope you do well on this assignment. Remember to ask questions when you get stuck. I'm always here. All right, that's it. Bye-bye.